In some boilers, the air supplied to the combustion area is preheated. Preheating the air raises its temperature closer to the point where ignition occurs. This, in turn, helps to ensure efficient and complete combustion. One way to heat the air flowing into a boiler is with a rotary air heater, or preheater. This one consists of a series of heating surfaces, or elements, which are connected to a motor-driven shaft. The top half of this heater is in ductwork that routes hot combustion gases from the boiler through the air heater and on to the stack. The bottom half is in ductwork that directs incoming air through the heater and on to the boiler. A seal prevents hot combustion gases from mixing with the air flowing to the boiler. The heating surfaces rotate through the hot combustion gases. So, in this section, the heating surfaces are warmed by the hot gases. Then, the rotating heating surfaces transfer heat to the cooler air flowing to the boiler. The warmed air is sent to the boiler's combustion area. With this design, heat that would otherwise leave through the stack unused preheats the air entering the boiler, so the boiler operates more efficiently. In this topic, we focused on airflow in a boiler. We saw why it's important to control the fuel-to-air ratio, and we looked at air heaters, devices that can improve boiler efficiency. Now's a good time to stop, so you can try some practice questions. The components typically used to provide draft are fans. There are two basic categories of draft fans: forced draft fans and induced draft fans. As their name implies, forced draft fans force air into the boiler. A forced draft fan draws air from outside the boiler and forces it through the burner into the combustion area. Induced draft fans create draft by drawing combustion gases from the boiler. The mixture of fuel and air supplied to a boiler is called the fuel-to-air ratio. It's important to maintain the proper fuel-to-air ratio to avoid combustion problems. For example, if the boiler is not getting enough air, some of the fuel entering the boiler won't burn. Instead, it may get carried out with the combustion gases and wasted. In some cases, unburned fuel could build up in the boiler. This buildup could cause an explosion if the fuel were ignited. One way to heat the air flowing into a boiler is with a rotary air heater, or preheater. For a boiler to produce steam, water has to flow through the boiler properly. One way to provide water flow in a boiler is by a process called natural circulation. This simplified water tube boiler illustrates how it works. The boiler has two drums. The upper drum is sometimes called a steam drum, and the lower drum is often called a mud drum. There's also a series of water tubes called risers, which carry a steam-water mixture to the steam drum. And this one has a downcomer, which carries water from the steam drum to the mud drum. Boilers normally have several downcomers. In addition, there's a feedwater inlet and a steam outlet. The water tubes in the lower drum are filled with water. The steam drum is only partially filled. There's enough space in the steam drum to allow steam to collect. As combustion occurs, the water tubes that surround the combustion area heat up. As heat is transferred to the water in these tubes, the water becomes less dense and lighter than the cooler water elsewhere in the boiler. Some of this water turns to steam. As a result, the heavier, cooler water flows downward into the lower drum, and the lighter steam-water mixture flows into the steam drum. Then, as the cooler water is heated, it too becomes lighter. It rises to the steam drum and is replaced by cooler, denser water. The steam flows to the plant through the steam outlet, and the water level is maintained by the water flowing through the feedwater inlet. As long as combustion takes place, natural circulation continues. Not all water tube boilers rely on natural circulation. In some cases, a circulating water pump is used to produce the flow of water in a boiler. This type of circulation is called controlled or forced circulation. In this example, the pump draws water from the steam drum and forces it through the lower drum and the risers. As the water in the risers is heated, a steam-water mixture is produced. Water from the pump forces the steam-water mixture into the steam drum. If the pump circulates the water through the drums and the tubes, the boiler will operate as it's supposed to. Hypothetically, though, if the pump stops, the water will no longer circulate properly, and the boiler could boil dry and become damaged. To make sure there is proper water flow, most controlled circulation boilers use 2 or more pumps. So, even if one pump stops, the other pump will provide enough circulation to prevent damage to the tubes. With this type of water tube boiler, water circulation depends on the differences in density between water and steam. Mechanical devices, such as pumps, are not needed. This method of circulation is called natural circulation. One way in which boilers are made more efficient is by heating the feedwater before it enters the boiler. If the feedwater is preheated, the boiler will require less fuel to produce steam. A device that's used to preheat feedwater is an economizer. Economizers are often used in water tube boilers. An economizer is basically a series of water tubes located in the flow path of the combustion gases. Feedwater is routed through the tubes on its way to the steam drum. The water is heated by the hot combustion gases flowing past the tubes. The economizer improves boiler efficiency by making use of heat in the combustion gases that would otherwise be wasted. The steam produced by a boiler generally contains some moisture. Some plant processes require relatively dry steam, so the moisture could be a problem. To prevent equipment damage from moisture, some boilers are equipped with moisture separators, devices that remove moisture from steam before it's sent to the plant. One type of moisture separator is a centrifugal separator, or cyclone separator, located in the steam drum. It works by directing the steam-water mixture into a circular chamber. The circular shape of the chamber causes the mixture to swirl around. The swirling action creates a centrifugal force. This force flings moisture droplets against the chamber walls. Then the droplets run back into the drum. The lighter steam flows out the top of the chamber. Some boilers use a dryer along with centrifugal separators. This design is often found in processes where extremely dry steam is required. This dryer consists of a series of V-shaped plates. The steam flowing through them has to make several changes in direction. The water droplets can't change direction as easily as the steam, so most of the droplets separate and drip back into the drum. The steam flows through the dryer and onto the plant. In this topic, we looked at water and steam flow in a boiler. We saw how natural and controlled circulation occur. We also looked at economizers and moisture separators. Let's stop now so you can try a few practice questions. With this type of water tube boiler, water circulation depends on the differences in density between water and steam. Mechanical devices, such as pumps, are not needed. This method of circulation is called natural circulation. Economizers are often used in water tube boilers. An economizer is basically a series of water tubes located in the flow path of the combustion gases. Feedwater is routed through the tubes on its way to the steam drum. The water is heated by the hot combustion gases flowing past the tube. One type of moisture separator is a centrifugal separator, or cyclone separator, located in the steam drum. It works by directing the steam-water mixture into a circular chamber. The circular shape of the chamber causes the mixture to swirl around. The swirling action creates a centrifugal force. This force flings moisture droplets against the chamber walls. Then the droplets run back into the drum. The lighter steam flows out the top of the chamber.